Now that we've discussed sampling and probability, we can now talk about inferential statistics. So if you remember from Module 1, inferential statistics is when we take the results of a smaller group, such as a sample, and we use those results as a proxy for the population. So in other words, we infer from our results with the sample to a larger or different population. That's called inferential statistics. Now the whole purpose of sampling is to infer. So whenever we have a sample, we have inferential statistics. When conducting inferential statistics, we need to develop a hypothesis. Once we have a hypothesis in place, we then have to test that hypothesis. In other words, what's called hypothesis testing. Let's first talk about what a hypothesis is. So by definition, a hypothesis is a testable prediction derived from a theory. Now it's important to know here a prediction is a statement, so it's not a question, so a hypothesis usually comes from a research question, but the hypothesis itself is a prediction or a statement about the relationship among variables. So not only is this statement predictive, but it also has to be testable. We have to be able to collect some data, some values, and we have to be able to test it using statistical methods. Now not only it has to be testable, not only must it be a predictive statement, but it also has to come from some sort of theory. So there has to be some reason for us to test this prediction based on the research that we may have conducted prior to our study. So let's go through an example of creating a hypothesis statement. So here's a picture of my daughter, Katie, when she was 5 years old. So she watched Star Wars quite a bit when she was younger, and her favorite character was General Grievous. And so for Halloween, I decided to make her a General Grievous costume. And so as a concerned parent, I may wonder if the level of Star Wars watching for Katie, whether or not it's affecting her aggression. So Star Wars tends to be a violent show, and so violent media based on observational learning increases aggression in children. So there's a theory, observational learning, and so I may wonder whether Katie's watching a Star Wars is making her more aggressive. And so that's my research question: does watching Star Wars increase aggression? And so I had a theory based on observational learning that when children watch violence or watch aggression, they tend to imitate it. And then I had a research question based on behavior of my daughter and her viewing habits. And then I can turn that into a predictive statement, in other words, a hypothesis, which states that maybe, and not just for my daughter, but for children her age in general, that watching Star Wars causes aggression in 5-year-olds. So notice it's not a question, it's a statement, it's a predictive statement that watching Star Wars causes aggression in 5-year-olds. In other words, children who watch Star Wars become more aggressive. And so in this case, I had a theory, observational learning. I generated my hypothesis from a research question. Is my daughter becoming more aggressive because she's watching Star Wars? And I take that and I turn it into a hypothesis. In this case, watching Star Wars causes aggression in 5-year-olds, a predictive statement. Once I have developed a hypothesis, I then need to test it. In other words, what is called hypothesis testing. So I can't just have a hypothesis and test a hypothesis by itself. I have to test it against another hypothesis. In other words, I have to make a comparison. And so hypothesis testing is when we compare two hypotheses. One hypothesis we'll call the null hypothesis, and the other hypothesis we'll call the research or alternative hypothesis. The research hypothesis is a hypothesis I'm really interested in. The null hypothesis stipulates that there is nothing going on among my variables. Let's first talk about the null hypothesis. So the null hypothesis states that there's no difference between our groups or among our variables. So in this particular case, if I'm looking at Star Wars and its influence on aggression, the null hypothesis would be that there is no difference in aggression between children who watch Star Wars and children who don't watch Star Wars. In other words, we're saying that Star Wars has no effect on the aggression level of children, so nothing's going on. And so we must assume that until we have some evidence to suggest that children who watch Star Wars become more aggressive, we must assume that Star Wars has no effect on the aggression level of children. And so we'll always assume that the null is true until we have enough evidence to reject that null hypothesis. The alternative hypothesis is what we call the research hypothesis. And the research hypothesis states that there is a difference among our variables. So in this case, we could state that there is a difference in aggression between children who watch Star Wars and children who don't watch Star Wars. The alternative hypothesis is a hypothesis we turn to if we reject the null hypothesis. So if we reject that there is no difference in aggression between children who watch Star Wars and children who don't watch Star Wars, then we find support for the research hypothesis. Now the support or lack of support that we find for our research hypothesis is related to the research decision, or what's called the statistical decision. So the research or statistical decision is based on the math that we conduct with our statistical tests, so the numbers that we calculate. Now note that this is different than the practical decision, and we've talked about that several times already in class, that the statistical decision is based on the calculations that we have based on the math, and the practical decision is based on all the evidences that we have collected. So realize our calculations, our statistics, is just one piece of information or of evidence. So when it comes to a practical decision, we need to weigh that with all the other variables that matter. Alright, so as we noted in the previous slide, we will always assume the null is true until we have enough evidence to reject the null hypothesis. Remember, the null hypothesis is that there is no difference among our independent and dependent variables, or among our variables. So when we give a statistical decision in hypothesis testing, that statistical decision will be one of two things. Either we're going to say we failed to reject the null hypothesis, or we're going to say we reject the null hypothesis. If we say we failed to reject the null hypothesis, what we're saying is that there's no difference among our groups. So if we fail to reject the null hypothesis, what we're saying is that, in our particular example, we're saying that Star Wars does not cause a difference in aggression between those children who watch it and those who don't. So in other words, there's no difference, and it appears that Star Wars has no effect. And so if you look at the statement, failed to reject the null hypothesis, that's really what it's saying. You have a null hypothesis that says there's no difference among our groups, and we fail to reject that null hypothesis. Now, if we find statistical evidence to suggest that there is a difference between our groups, then we will say we reject the null hypothesis. So the null hypothesis being that there's no difference, and so if we find a difference, we will reject that there is no difference. So the two terms that we will use for our statistical decisions will either be fail to reject the null hypothesis or reject the null hypothesis. We'll never say accept the research hypothesis. We will never say accept the null hypothesis. Everything that we frame is in terms of the null hypothesis because that's what we assume to be true until we have enough evidence to suggest otherwise. So either we will say fail to reject or we will say reject the null hypothesis. With any given research study, we need to write both a null and a research hypothesis statement. And so when we're writing hypothesis statements, we need to include four things. We need to include some sort of difference statement, so maybe it's a difference between two variables, or there's no difference between two variables. We'll talk about other alternative difference statements, but right now we'll stick with that one. So we need to provide some sort of difference statement. We also need to identify who or what is being measured. We also need to include the measurement itself. And then finally, we need to include our groups, or what we're comparing. So whenever you write a hypothesis statement, you need to include these four things. A difference statement, so either there is a difference or there's no difference. Identify who or what is being measured, in other words, your population. Include the measurement as well, which would go hand in hand with the population, because whenever you describe a population, you include the measurement. And then also mention the groups that are being compared. So those are the four things that you're graded on when writing a hypothesis statement. So provide a difference statement, identify who or what is being measured, identify the measurement itself that they're being measured on, and identify the groups that are being compared.